Hello friends, my name is Shiprakash Singh and you are watching BI&DataScience.com. Today's video we are going to learn about joins in SQL and subqueries. Today's video is part 3 in a 5-part series that helps you learn and master SQL. In part 1, we covered fundamentals of database, how are they different than flat files, why do organizations store large amount of data using database. We also touched into the difference between a relational database and no SQL database or non-relational databases. Then we talked about the ACID property of databases, covered the basic structure of the select statement. Now select statement is the only statement that is used for data query. We also talked about the data definition language, data manipulation language, also the transaction control languages, and talked about the where clause, the order by, and the limit clauses. In part 2, talked about advanced filtering using keywords like in, not in, like operator, between, and we also learned about regular expression. We saw how powerful a regular expression is to do a complex search inside string columns. We learned about grouping and aggregations using the having clause, and finally touched about data transformations. I also made another video where I show you how to download and install the open source MySQL. Also walk you how to download the sample data sets where you can do a lot of hands-on exercise. And most of the hands-on exercise that we are doing in this tutorial series are based on the SQL database. SQL database is one of the sample database that you can download. It is all about a movie rental business. There are other free databases like the employee database and the country database. You can learn all those information in that installation video. In today's video, we are going to talk everything about joins. Why do we do joins in SQL and how many different kind of joins are there, and if you watch this video till the end you will be an expert in joining different tables in SQL. Don't go anywhere, we'll jump in right after this short break. To understand joins in SQL, you need to understand about the data splitting. Why do we split data in multiple tables? Because we want to preserve the ACID properties. To remove the duplications, we are fragmenting data and we are storing them into different tables. Now, this entire process of fragmentation is called normalization. This is done during the database design phase by the database administrators or database engineers. They decide on what's the optimal structure of storing data in what number of tables. Those tables are then updated by the OLTP transaction systems. Once the business data is collected in these tables, we as a business analyst are asked to write queries or collect some particular kind of information from these databases. When we are going to fetch those informations, we don't find all the information that we are seeking in one particular table. The information may come from 2 tables or it may come from 3 tables or multiple tables. So in all those cases, we use join. What it means is we are trying to pick some information from one table and then the other part of the information from the second table, maybe if required third or fourth table, and then we are trying to collect all that information in one report. The data is too much fragmented, and if we have to join too many tables, queries become slow and it takes a lot of compute, especially if you are trying to join tables with large volume of rows, which always happens in real life. The tables that you'll be dealing will have large number of rows and columns. So in all those cases, most of the time, database administrator or data engineers will have something which is denormalization, which is opposite of fragmentation. So they would have already joined certain tables in such a way that you don't have to join on frequently used information. Why we need join? First, we need to store data. To store data, we split them into multiple tables so that we don't run into redundancies. We preserve the ACID properties. This process is called normalization, which is done in the data design phase. And once the data are collected in these tables, when we go and query, we often have to collect data from multiple tables. So we either join tables or there is some degree of denormalization, which is again a process of joining tables together and make one big wide table. It's also called as wide table because you are increasing the columns. All the examples that we will be doing in this series are based on the Sakila database. Now, Sakila database is a sample database which is already available during the download and installation of MySQL. If you watch the MySQL download video, you will see how we have downloaded the Sakila database, and we also ran some queries there. But for our new viewers, I want to give an idea, like there are around 16 different tables in Sakila database. Most important of them are 5 tables which I have listed here, which is the film table, which captures all the information related with the movies. There are stores which are carrying these film to rent for users, and all of that information is captured in the inventory table. So inventory table gives you information about what store is carrying what kind of films, and then customer would rent one of these inventory, and their rental information we are storing in the rental table. To give you a quick idea of some of the features or attributes available in these tables, I'm listing here the most common features. So there are lot many other fields or features in these tables, but for example, in store table, you have the store ID, which uniquely identifies the store. You have store manager information and the address of the store. In inventory table, we have the information about the inventory ID, which is a combination of the film ID and store ID. And then each of these inventory can be rented by customer, and that information is stored in the rental table. So in rental table we have the rental ID and the rental date, that is on what date the customer is renting the movie. And then we also have a return date. This is on what day you are returning. So this is what day you are taking the rental, and this is what day you are returning the rental, and what inventory ID he is renting. So that will have information about the film and the store. Then we have the information about the customer as customer ID. We have a different table called customer, where we store the customer's first name and last name and the home store ID for that customer and the address of the customer. And then all the information related with films we store in the film table, where we have the information like the title of the film, description of the film, the release year, so on. You can see these are the most important tables and their important columns on which we are going to practice writing query today while we understand the concepts of join. To give you an idea of why do we need to join tables and how join works, suppose we want all the rental information by date with the customer's first and last name. Now, if you are tasked to write this query, and this is the database you are looking, so you'll say, okay, I can find customer information in the customer table, but in customer table, I only have customer ID and his first name and last name. I don't have what rental he has taken. To find those rental information, we need to go to the rental table. Now in rental table, we do have the information about the rental date, which we want. What date the rental was taken by the customer, but we want the name of the customer. We don't have the name of the customer in the rental table, but what we have is the customer ID. And we know using this customer ID in the customer table, we will be able to find the first and the last name of the customer. Now it all makes sense, right? We want to find the information about all the rentals by date taken by the customer's first name and last name. To do that, we can find the rental information from the rental table about the rental date and the customer's identifier, and by using that customer identifier, we can find the customer's first and last name. It is intuitively clear. We want some information from rental table and some information from customer table. So we have to join these tables together. How do we join? So to join two tables, think of this way. Suppose we have the rental table and we have the customer table. So whenever you are joining two tables, there has to be a common column. Now that common column you can see is customer ID. It is in customer also, and customer ID is in rental also. So your common column is customer ID. In one of the table, your customer ID has to be a unique identifier, and that will be in customer table. Here customer ID is unique because that's how we can identify each and every customer. In this table, the customer ID is called primary key because primary key is column that can uniquely identify all the records of that table. And in the rental table, customer ID will be repeated because a same customer can have many rentals. If I'm a movie fan, I can rent a movie every week. So I will have 52 records in a year in the rental table. My customer ID will be repeated in the rental table. In rental table, this customer ID is called reference key. It's called customer ID is called reference key or foreign key. Why? Because it is a key or it's a column that helps you look up the value in a foreign, means another table, or it's a key that will be referenced to another table. That's why these language and terminology are important, because when you are working as a data analyst and you join a team and some of your team members say, hey, this is the foreign key in this table, go and use this, or this is the reference key in this column. So just make for clarity, they are all same. So foreign key is sometimes also called as a reference key, and the table that contains the foreign key is called the referrer table, and the table in which it is referencing is called the reference table. So now you can understand the customer ID here is a foreign key, is going to be combined with the customer ID in the customer table where it is a unique key. You know all these concepts around foreign key, primary key, reference key, right? Referring table, referral table. So let's go ahead and write this query to have some fun. We know we write all the columns that we need after select. So let's first say we want to select the rental date. We need the customer first name and we also need the last name. You can write a query on multiple lines to increase your readability, as well as when you are trying to debug or when you get the logical error, it's more easy to read and comprehend what's happening. So we are selecting the rental date, first name, last name. I got all my columns. Then next, what do we write? We write the from thing. Where are we going to pick this information from? So let's write the tables where we need this information. So we need this information from the rental table. Now I need to join my rental table with the customer table. So I can say join and then I'll say customer. Now you just learned whenever you need to join two tables, you use a common key. And to specify that common key, we use the clause called on. So we are trying to join rental and customer on, because SQL needs to know you want the customer ID of the rental table equal to the customer ID of the customer table. So I'll say rental dot customer ID is equal to customer dot customer ID from agent. So I got my date, I got the first name, I got the last name, the tables are joined, I joined them. I don't have to filter anything, so my where is, I don't have to have any where, I'm not grouping anything. So all now, just to make the query look good, I'm going to order it by the rental date so that you see the more recent rental at the top and the old rentals at the bottom. Order by rental date, and this is it. Now I can go and I can run this query, and you see, nice and beautiful. You have rental date and the first name and the last name in the output. Now you know this information is coming from the rental table, and these two informations are coming from the customer table. So this is how join works. Now, few things to remember here. Whenever you are joining two tables, most of the time there may be the same column name in the both table, and to so that you saw like to reference the customer ID in rental table, we use a rental dot. To reference the customer ID in customer table, we reference it by customer dot. To reference a particular value from a particular table, we use the table name dot column name. So here we can say rental dot customer ID. Now this thing will run. But the rental date and the customer ID, which I know is coming from the rental table, and the first name and the last name is coming from the customer table. Because these table names are quite big, in real world they have big table names. So every time if I have to write a big query and there are like I'm fetching 10 rows, I have to type rental dot or customer dot 10 times. So to shorten our effort, what we do is to shorten the name of the tables, we use alias. Now how do we use alias? We can say from rental as, I can say it as R, and I can say customer as C. Now everywhere where I have rental, I can just replace it with R. I can say R dot customer, and I can say C dot customer, and here I can say R dot customer. This will give me the same output because I'm not doing anything. I'm just saying the rental table will also be called as R, and whenever I say R dot, that means rental dot. The customer table will be called as C, and rather than now typing customer whole 7 8 alphabets, I can just say C dot. So it's much easier to write. So if I now run this, I'll get the same output. However, R and C are not that intuitive. So most of the time, like I personally use 2 to 3 letter word, which gives me a little bit more context. Like here for customer, I can use the short as cust. For rental, I can use rent, and then I can modify all of them. I can say this is the rent dot, this is the cust dot, and then this is rent dot. But this is purely your preference, it does not matter. Programming querying is just like solving math problem, and in math problem people may take different variable names and different names. You can even use here for rental, I can use as A, for customer I can use B, and I can say A dot and B dot. It's all same, it does not matter. However, I recommend you use some sensible name, because when you're working in a team, you want to make sense for different people so that your code is not only readable to you, but it's also readable to others. If you're writing a code that only you can comprehend and you're working in a team, other people will start disliking you, right? They will not like you because they don't understand what way you write the code, right? So develop a programming habit, and sometimes you learn these habits in the team, but I would say these are industry wide practiced habit. So I'll say use 2 or 3 letter word. That makes a lot sense, like cost, rent, sales, inventory. For inventory you can use INV. You got the point. We learned why do we join, what are primary keys, and what is foreign key. Now let's understand how many types of join are there in SQL. 6 type of joins that are possible in SQL, and they are inner join, left join, right join, full join, cross join, and self join. If it feels like these are too many joins, don't worry. You will have a complete clarity about them if you watch till the end. And I'm going to explain the intuition behind all of these joins. Programming, querying, maths, they are all same. They are mastered by practice. Here is another interesting question that can come to your mind. I told you 6 type of joins: inner join, left join, right join, cross join, self join. But when we wrote our query, we only use the word join. So is that join the 7th kind of join? No. So by default, Join means inner join. The default join is always a inner join. So let's understand the different kind of joins. So suppose I have two table. I have one table as A and I have other table as B. Now these are all the records. Table A has 100 records and table B has 200 records. And whenever I join them using the inner statement, so whenever I say inner join A and B, it will return you all the records that match in both the table for that value. For example, when we wrote our previous query and when we connected the rental and customer tables on customer ID, all the customers who were present in the rental table who have rented at some point of time, only their information will come from customer. So there might be more customers who never rented, their information will not come in inner join. So in inner join what happens is only the common information, the common records that are available in both the tables for that join column value, they will be fetched and returned. That's your inner join, which is your default join. There might be a case where I need all the records. So in this case, I need all the records of customer along with their rental, how many times they have rented. For those cases, I would like to do a right join because I need everything from customer table and the matching information from the rental table. So whenever you have everything from the right side of the table and the matching, you use right join. And in cases when I need everything from my left table, say for example, I need everything from rental table, even if customer information doesn't exist for that, then I will use a left join. In that case, I will get everything from my first table plus the matching. I will get this portion. So left join will give me this much. Right join will give me, I will say in the red color, right join will give me this much. If I do the full join, I will get everything. I'll get all the records from table 1 and the records from table B, which obviously includes the common records as well. So I will get the everything. Now, whenever you're joining this table, because the common records will have value for all the columns, but your left table will have null values for the attributes that are not found in the right table, and the right table will have the null values for the attributes that are not found in the left table. Full join will return you all the rows but with lot of null values, which would be null for the records that don't have value in the other table. If you learn inner join and left join, you're good, because the right join you just have to swap the order of the table, and for some cases we do need the full join. It's not that widely. One more thing, again, it's just a term, as I tell you, when you're working in an industry, they are also referred as outer. Like sometimes the left join is also called as left outer join, right join is called as right outer join, and the full join is also called as the full outer join. Focusing on inner join. Now here you can see more clearly, this is your table A and this is your table B. Inner join is returning all the results that is in common in both the tables. I want to find all the rented films along with the customer who rent. Last time we found all the rental date and the customer names who took the rental for that date. This time I want the same report but also with the film title. So I want the name of the movie, the date of the rental, and the name of the customer. To write that query, you can see here we have customer first name and last name in the customer table. So we have customer first name, last name in the customer table, and in the rental table we have the rental date. We want the movie's title or the film's title name. Now film title name is in the film table. So you have to first figure out how does it join, because film ID is not in the rental table. So I cannot join rental with film. It becomes tricky. When I cannot join rental with film, what can I do? Then you have to look carefully. Information about film is in the inventory table. Here we have the film ID. And this inventory ID is in the rental table. So I can get the film ID from the inventory table. So if I join my rental table with the inventory table and the film table, I will have the information. Let's write this query. So we need the information from three tables. That's okay. But what are the columns we need? We need the film title. So let's first type that. Say select. We need the title. So, and again, you learn we will use the alias to shorten. We will use the alias F for film, R for rental, I for inventory, and C for customer, so that I don't have to type long names. So I'll say F dot title, because that gives me the film name. And then I need the date. Now date is inside my rental table. So I'll say R dot rental date, small d, and then I know my customer's first name and last name is in the customer table, so that will be C dot first name and then C dot. So I got all my columns. So this is done. Now let's write from. We are starting everything from the rental table, because the rental table has inventory and the inventory has film, and rental has the customer and the customer ID. So let's start with the rental table because that has most of the keys. So we'll say from rental as R, and then I am joining now rental with my say first inventory table to get the inventory ID. I will say inner join inventory as I on. Now the inventory ID is the common field between inventory and rental. So I'll say R dot inventory ID is equals to I dot inventory ID. So now my inventory and rental tables are joined. Now let's join inventory with the film. So I'll say inner join film as F on the common column now between the inventory and film is the film ID, and we are saying inventory dot film ID and the film dot film ID are same. Inventory dot film ID is same as F dot film ID. And so this is now, so far my rental, inventory and film are all joined together. I also need to join my customer table to get the first name and last name. So I'll say inner join customer as C on R dot customer ID is equals to C dot customer ID. So I have all my join. Now I can order it by either date or I can order it by the movie title. It depends on you how you want to order it. I can say order by F dot title, followed by, for every movie I want the recent date first. So you can use multiple columns in order. So first I want to order it by movie name and then the rental date. I can say F dot title and R dot. Okay. Using IDE is always helpful. We learned in the download video of Python and VS Code. If you use IDE, if sometime it will give you red underscores, which tells you are making an error and you can correct yourself. So this is it. If we run this, we should know the name of the movie along with the rental date of that movie and which customer rented it. Let's find it out. So the movie Academy Dinosaur was rented on date this by Sergio Stanfield Norman Career, and you can see we got a title, rental date, first name, last name. So here you can see we joined 1, 2, 3 and 4 tables. So we joined rental, inventory, film and customer. So you can join many tables. In inner join you can have many tables, in left join you can have many tables, in right join you can have many tables. It does not matter. MySQL or most of the relational databases, they will not give you an error if you are trying to join many tables. But the catch is the speed and the compute. So if you're joining large tables, firstly, it's going to slow down your query speed. Secondly, if you are using cloud services, there is a cost associated with every query. So on-prem, you make the investment one time and then you write the query. But when you are querying on cloud services, your query cost is computed by every query by the amount of time it takes to run along with the number of rows it pulls, right? So there is a query cost associated. If you do too much of joins, one, the speed slows down, then it also incurs a lot of compute cost. So that's why a lot of time your administrator will already do a data denormalization. They will already join some of the commonly queried tables together. All of these concepts are explained in our fundamental video. So if you want to master SQL, I would recommend watch the video 1, 2, 3, watch every video in the series. Most of the videos that I make are a little bit longer. I try to go a little bit slower because my focus is to make you understand the entire concept. It's not about showing you some sample queries, but my intent is you understand the logic, you understand the concepts, because then you can go and practice yourself and that will help you become an expert in the long run. Now let's do some example on the left join. Now you see I have written here left and left outer because they are the same thing. Left and left outer join are same thing, depending on different people will call it differently. This picture is also clear. We saw in left join what we get is we get the entire thing from a left table and the matching rows from the right table. So you see, for example, the question may be find all the customers with their recent rental date, including who never rented. So I want list of all customers along with their most recent date of their rental, and if somebody has never rented, their recent date will be null. Now you can make sense, like I need information about all my customers and their rental activity. So obviously, which table do I have to keep in left? The table where I need all the information. And which table do I need all the information? Customer. So the customer goes in left. Start writing the query. So first thing first, we need to select all the customers' name and they are in the customer table. So we say C dot, again we are using C as an alias for the customer table. C dot first name and C dot last name, and we need their recent rental date. Now rental date is in the rental table and we want the recent date. So again remember, rental date will be repeated for a customer because I may have rented 10 times, so I'll have 10 different dates. To get the recent date, I'll need to use some kind of a aggregate function. Now what function do I use? Which is my date value should be the maximum. That will give me the recent date. So I'll use max of the rental date, and that is in table R. So I say R dot rental date, and then I can alias it as, so you can alias a table, you can alias a column. So I'll alias, if I don't alias in the output, the column name will be max rental. All these concepts are explained in the video 2 of the series where we do a lot of hands-on exercise, or we just call it recent rental date. So we got all our columns. Now let's figure out the tables. So we need from, again we need from customer, because I want to keep my customer in the left because I want all the information from customer. Whether the information is in the rental table or not does not matter. I want everything from customer, and if it exists in rental, I want the common information. If it does not exist, I need the null values. So my customer goes in left. So I say customer as C. Now because I'm doing a left join, I'll say left join. Second table is my rental as R, and again on C dot customer ID is equal to R dot customer ID. This is it for the from thing. Now remember, I have used a rental date to find the most recent date for a customer. So I will now have to group it on a customer, right? So I group it on customer ID. Group by C dot customer ID. I want to order it by the recent rental date. So order by, and I can use this alias column as here. This is it. Now let's run it. See, I got the first name for Herbert Kruger. The recent date is 8/17 of 2005, right? So you saw, whenever we need the entire rows from a particular table, we use the left join. If this is the example, like I want to find all the movies with the number of times they were rented, and now there might be some movie that are never rented, so I want all the movies. So obviously which table will go on left? My film table has to go on, and because film ID is in inventory ID, so my second table would be inventory, and then also because I need the number of times they are rented, which is available in the rental table, I'll have to join the rental. So I have to join the film, inventory, rental, where my film is on the left and inventory is on the left of the rental. So again, I say select F dot title, and then I can have count of R dot rental ID as rented times from film as F, left join inventory as I on F dot film ID is equals to I dot film ID, and then this I can left join with the rental as R on I dot inventory ID is equals to R dot inventory ID. Now because I'm grouping it on the film title, I say group by F dot title, and I order it by rented times DSC. This is it. The Bucket Brotherhood was rented 34 times. Rocket Mother was rented 33 times, and so on. Let's find out if there was any movie that was not rented. So if I want to find all the movies that were never rented, I can say rented time is 0. Because it's an aggregate function, this count function is running on null. So because if they are not rented, they will not have any rental ID, so it will be 0. Okay, so now you can see the power of left join. Whenever you need everything from the first table, always use a left join. Now right join is a opposite or the mirror image of left join, where you get everything from the right table and the matching records from the both the tables. Often if you struggle to comprehend or write right join, you can flip your table and you can write most of the queries that you can do using right join. You can also do it using left join. That's why I said most widely used joins are inner and left, because right is opposite of left. So let's do an example on the right join. Here you can see the right join or the right outer join, they both are the same thing, are explained as where you get everything from the second table including the common area. So this is your right join. So let's do one example of right join. Now many a times as an analyst we are asked to write questions about the out of stock inventory or the stock inventory in e-commerce and CPG domain. So in this movies business domain, the question might come like, find all the stores and the number of movies available in each store. Not all stores may have all the movies available. Some of the movies may be out of stock as well. So how do we write that query? Keeping the store on the left side, we want the inventory on the right side. So we want everything in the inventory. So we only want the stores having the stocks. We don't want the store that does not have the stock. That's why we use the right join here. To write that query, let's open a new tab. So first thing, I want the store ID and I want the stock. Store ID is in the store table and the stock is in the inventory table. So I write select s dot les s dot store ID, yeah, and then I want the total stock that's available in inventory, that is nothing but the count of the inventory ID. I dot inventory ID as stock count from. Now I join my store and inventory, but I want all the inventory for the common matching store, so I keep inventory on the right. So I say from store, which is on the left side. Okay, there are two from store, and I say right join my inventory as I on. Now what is the common field? Store ID. I say again, I need a alias here for store as well, so I say as s and I say on, and you can write it on multiple line. It's just for readability. It does not matter for SQL to understand how many lines you have broken your query. SQL does not matter. I say s dot store ID is equals to I dot store ID. I want to group it by inventory store ID because inventory is on the right, so don't group it by store ID s, because store ID will only be for matching rows. For other store IDs may be null. So see, we have two store. For store the stock count is 2000 and for store 2 the stock count is 2000. So we learned inner join, left join, right join. Feeling pumped up? Let's look at some other powerful joins, which is the full join. Here is the trick. MySQL does not support full join, so I wouldn't be doing any hands-on exercise for full join in this video. But if you are following me on the Python series, then when we do the Panda and we try to do data manipulation in Python, Panda supports full join, and there we'll do more examples on join. So we'll see the example on full join there in that video. So like the channel, subscribe the channel, hit the bell notification so that you are getting all the latest release videos published by us. And once we start learning data manipulation in Python using pandas, we will definitely do examples on full join. So what does full join means? Intuitively think of this way: the entire thing is a full join. So you get everything that is in table A, irrespective of whether it's in B or not, and you get everything in B whether it is in A or not. So you get in MySQL, if you want to replicate a full join, what you can do is you can do a union. You can say select from A union select from B. Now that is similar to full join. We will do full join in Python pandas, and if you're using any other database, like if you're using Spark, Databricks, PostgreSQL, they all support full join. It's only MySQL, it doesn't have full outer join. But still we can do it using union, and we will learn about union and set operations in the bonus part of this series. We are going to make bonus series only when we get 1000 likes on this video. Comment us what else you want to learn in joins. So we understand the concept of full join. It takes all the records from A or B. This is the fifth kind of join, which is the Cartesian product, or called as cross join. Now, this is powerful join. It's not commonly used, but it's used in special cases, and you will run into cases where you'll have to use it. And it is one of my favorite join, even if it is not commonly used. So what happens in this join is, for cross join, it's like a cross multiplication. It's kind of a cross product of two relation. It's a Cartesian product. So it gives you all possible combinations. So in first table, say if you have three records, so in first table, say you have A1, A2, A3, and in second table you have B1, B2, B3. And if you cross join them, to cross join you don't need any condition or any common field, because it's trying to find all the possible pairs, right? So you don't need a common. This is the only join where you don't need a common field. So in interview questions, if there is a trick question asked, can you think of a join where you don't need any common column to join two tables? Don't get confused. There is a join, and that's the cross join. To do cross join, you do not need any common field to exist in both the tables. So any two tables can be cross joined. All it will do is it will take all the records of those two tables and make for every A1 it will create a B1. So it will create A1 B1, A1 B2, A1 B3, then A2 B1, A2 B2, A2 B3, and it will have A3 B1, A3 B2, and A3 B3. So you will have total 9 records. So this is what your output will look like. So this is what is happening. For every A1 you are getting 10 records in one table and 20 records in other table. If you cross join, you will get 10 into 20 records. In the circular database, as an analyst, if you are asked, hey, give me all the possible combination of customers and the category. And remember, the category are like drama, comedy, action. So I want to make a skeleton where for every customer I have all the film categories, so that if I'm trying to run a promotion or if I'm trying to run a combination of marketing campaigns, I don't lose any customer, any category. May be tempted to find all the customers, the movie they have watched, and the category of those movies, and you create a distinct on customer ID and the movie category, you may think you are getting all the customers and the category, but what you are getting is the customers who have watched different kind of categories. But there might be customers who have not watched other kind of categories, so they won't get the promotion, right? So to make sure your left table has all possible combinations of customer and category, you have to do a cross join, and this would be easy. So let's go and write the query. So all what we can do is we can go here. So we can say select, and because we want customer and customer information is in the customer table, we'll say c dot customer id comma c dot customer name c dot first name, c dot last name. Here you have the category ID and the category name, right? So I want here, now you see, because if we use the one letter C, we have customer also starts with C, and we have the category table also starts with C. That's why in the best practice I told you to use 2 or 3 letter acronyms for aliases. Or just I can use cat for category, cat dot name, because that's my category name. And then I can say from my first table is customer as C, and then because I don't have my other table, I can just put a comma and I can say category as cat. That's it. It will join, you see. You have Mary Smith travels, and for Mary Smith you have sports, for Mary Smith you have sci-fi, for Mary Smith you have new, for Mary Smith you have music, horror, games. You have all combination for Mary Smith. Then for Patria Johnson you have the same all combinations. So you can either use a comma, just like you have multiple column names after select. If you have multiple table names after from, it is going to do a cross product. Or if you can mention the word cross join, but you don't have to specify any column, right? So this is it. It will run. It will give me the same output, right? So this is all about cross join. Now cross joins are very helpful if you are trying to create a skeleton. Most of the times it's called a skeleton, where we want to put all the combination of possible values, and with this we will always keep this table in the left, and now we try to join all the business tables with this skeleton as a left join, where we are putting this all combination on the left side of the joins. It's one of wide use cases. Hopefully that makes sense to you and you are understanding these concepts. If you have any doubt, if you want any clarification, or if you want us to make any video on any component of any aspects of join that I'm missing, put them in the comment, and either my team will reply to your comments or we will make additional videos to clarify your concepts or doubts. The other join is the self join. In self join, what you are trying to do is you are trying to join the same table with itself. That's the whole idea of self join. So you have table A, and you want to join the table A with table A on certain conditions, right? So that's an example of a self join. So here you can see we are joining A with A, A2 on A2, and A3 on A3, and they are the same table. So this is suppose table T, this is also the table T. So we can join the same table with itself. That's the whole idea of self join. One of my favorite case, that's not in this schema, One of my favorite question in interview, and you may also get it asked, is there is an employee table. So employee schema is also available with MySQL. So in the employee table, you have a table about the employees, and in your employees table, you have employee ID, employee name, and you have employee manager ID, because every employee has the ID of his manager. So you have the employee ID, employee's name, and employee's manager ID. Now employee's manager ID is also an employee, so he will also have his information in the same table. So the question would be, find all the employee names and their manager names. Okay, so I want all the employee name and the name that would be for their manager ID, which would again come from some other row in the same table. So his manager ID would be somewhere here. So this thing has to join with that, right? All the managers of the staff of a store. So all the staff that work in a store, the store has a manager for that particular store. So the manager of the store is technically the manager of all the staffs working in that store. So now what I want is, I want the name of all the staff. I want all the staff name along with their manager name. Now in this case, the manager is the manager of that store in which all these staffs are working. So to solve this problem, staffs have a store ID where they work, and the store has a manager ID to whom they report. So we will try to join the staff and the store table. And because manager ID in the store table will also be a staff in the staff table, we'll be joining staff table 2 times. And that is how we are doing a self join on staff table. So if we have to write this query, how would we write? So first let's try to find the first name and last name of all the staff. So that is easy. We'll say select. And because I'm using staff 2 times, my first time let's call as SSF. Means first staff for first table for the staff. So rather than calling S1 and S2, I can call the same staff table 2 times, S1 and S2. Let's call it SF, and then next time I will call it SMG for manager. So I'll say S_SF dot first name, comma, SSF dot last name. Right, so I got the staff name. I also want the store ID, so I'll say SSF dot store ID. Now I want the manager name, so I will call that as SMG dot first name. This is also the same staff table, but this time this is coming from the second alias, comma, SMG dot last name. Now I say from staff as S_SF, right? So first staff table, and I'm joining it with the store table. So I'll do, and I keep on my staff on the left, so I'll left join. And this time I join it with the store, so I say store as ST on SSF dot store ID is equals to ST dot store ID. So I join my staff table with the store table to find the store ID of all the staff who are working in that store. Now I again want to join same staff table with the store table, but this time I want to use the store's manager ID with the staff's staff ID. So I'll say this will be a inner join staff, and this time I'll say staff as staff mg s underscore mg on st dot store manager id dot manager staff id is equals to staff smg dot staff id. This is it. I can order it by the first name last name, but that's fine. Let's just run it. See, in our example we only have one record in each table. We only have two records and both of them are manager of themselves. That's why we get the output like that. But if there were more employees in store 1 in our output here, we would have got all the first name and last name from the store 1 along with the manager name for the store 1 on the right. So you got the idea of self join. So these are the 6 different kind of joins that you will encounter in SQL, and if you master all these 6 joins, you can fetch any data if possible from the data that you have by using a combination of these 6 type of joins. I'm sure watching this video you would have the conceptual clarity about these 6 joins. If you have any questions regarding any of the join, type in the comment. The another idea is about subquery. Now a subquery is a query inside another query. So we are kind of trying to ask question in multiple steps. Subquery is nothing but a select statement written inside a select statement. So sometimes subqueries are also called as nested queries because you are nesting one select into another select. And remember, in my first video I have explained the similarity of SQL with algebraic expression. Because you can nest one algebraic expression into another algebraic expression, you can nest one query inside another query, and the inner query is often called as the subquery. Query that is outside is called the outer query. So subquery is the nested inner query of any bigger outer query. So let's do an example. We wanted to find the name of the movie that was rented most. So we want the name of the most popularly rented movie. How would you find? So to find that, first we need to find the movie that is most popular. That is my one part of the ask. I can find my most popular movie, and then what I can do is I can go to the film table and find the name of that movie. So from my rental table, I can find the maximum rental, which movie has the maximum rental. And then from that, once I find that film ID, I can go to my film table and I can find the film title. So that is how a subquery is written. So suppose we want to find the name of the most popular movie. Popular movie means it has to be rented more number of times. So a lot of time you can do a backward problem solving as well. So let's first try to find the most popular movie. Now to find the most popular movie, what I have to do is I'll have to do say select. That would be nothing but film ID. Now this film ID is from the inventory table because the most popular movie is based on my rental table. Whichever movie has the maximum number of records in rental table is the most popular movie. But I don't have the movie name in the rental table. In rental table I have the inventory ID. So technically I'm trying to find my film ID from the inventory ID. So that's why I say I.film ID, which is nothing but the film ID in my inventory table, and I want the count max, count star as say count, right? And I say from rental as R inner join, or I can simply use join, it does not matter. I can say inventory as I on r dot inventory id is equals to I dot inventory id. So this joins my two table. Now I group by. So all I'm trying to find is which is my most popular movie. Group by, I'll say group by film ID, because my film ID is in inventory table. So I say group by film ID. I say group by film ID, and then I say order by film count or rent count, R count. I say R count descending, right? So if I run this, I'll see a list of all the films that are most popular in a descending order, right? See, so film ID 103 is rented 34 times, 738 is rented 33 times. So I got my most popular. Now I want to use it as an inner query to one idea would have been I can go and join this table with the film ID on film ID, but I don't want to do a join. I just want to use this query inside the query from film ID, and somehow I want to filter my film ID table for say film ID 103 because that's the most popular. So I'll have to do some tweak here because here I'm getting multiple records. So I'm most interested in the top one. So to do that we can say it limit 1, and that will give me the top record. And here also I don't need this column, right? This was only for us to understand, so I can just remove this column. Because I removed the R count, I'll have to use the count star here, and this will now return me just one value, that is 103. Let's run this and we'll be able to see. You see, I got my 103. Now I can put this entire thing in a where statement for my film table. So I can now say select f dot title from film as f, where f dot film id equals, and I can put this thing, whole thing inside the bracket. So what I'm trying to do is, again, you see how beautifully this IDE says this is all one. So what I'm doing is I figured out the most popular movie, and because I wanted the name of the most popular movie, I can here also say as f dot title as most popular movie, and this is it. This is it. See, bucket brotherhood. So here this thing is called as subquery because this is a part for the outer query. Now the idea is we can divide our query in multiple steps, and we can then build it bottoms up. So the thing that goes in the last, first think about writing that query and then trying to embed in the second step of problem, then the third step of problem, and you can have many subqueries in a query. This is how more complicated and complex big queries are written, because you can embed one query inside other query, another query inside the inner query, and another inner query inside inner query. So, and you can use subqueries in everywhere. You can use a subquery in select, you can use a subquery in from, you can use subquery in where, which is we are doing it right now, right? So you can use subquery in select or from or in where, right? So here in this case, we could have got the same result by doing a join. We could have joined our film table with our inner subquery on film ID, and then we could have limited the top record using the limit in the end. But in that case, think of this way: when you are in doing something in business, doing joins are complicated, and sometimes it's preferred to do a subquery because I want to fetch a very small data set. Now, in our case, our subquery is returning one record. That's why we are using with a equal sign in where. There might be cases where your inner query returns many records, right? In that case, we can use here in, because using in operator, we saw we can compare it with many values, right? So I can say here limit 5, right? Now I will get my top 5 popular movies. Let's see. Our query was giving error because we could not use in with a subquery having a limit. So it's a clever trick. I put all my subquery. So all this thing, this was my original subquery. I created it as a temporary table and I called it as top movies. Then I selected the film ID from this temporary table, which is another subquery, and then I selected the title for all the movies whose IDs were found in this second subquery. So this way, if I run this, I can find my top 5 most popular movies. Now this way you can see I have written a query inside another query inside. Here this query is used, the second query is used in the where clause, and for that query itself the second query is used as a from table statement. We will learn more about subquery in the coming video, but so far I think you have understood why we join tables in SQL, what are different kinds of joins in SQL, and then we learn an introduction to the subqueries. So friends, if you are liking this video, please like, subscribe, and also share this video with all your friends who want to make a career in field of analytics and data science. And coming up in our next video, we are going to talk about subqueries in great depth. We'll also cover a difference between correlated and uncorrelated queries. We'll talk more about window functions, and we'll also learn some additional function on string and date columns. Hit that bell notification so that you are notified whenever we are releasing the new videos. I'll see you in the next video. Until then, happy learning.